Mount Stromboli erupts at 6:46 p.m. local time on July 3, 2024. Italy's most active volcano aka Mount Stromboli put on a show, as suddenly part of its main crater wall collapsed. As the collapsed material and cooling lava fragments tumbled downslope, they progressed into a superheated pyroclastic flow, racing about one-third the way down the mountain before temporarily ceasing its forward motion. Then, 7 seconds later, a second pyroclastic flow struck which advanced all the way down Stromboli's northwest slope, entering the Mediterranean Sea. This hot cloud of material then not only entered the sea, but also a less dense section of it flowed more than 1,000 feet above the water before stopping. Although no one was harmed, someone easily could have been if they had hypothetically stood in the path of these two pyroclastic flows, even if they were present on a boat. Why exactly? Simply put, while pyroclastic flows can vary in temperature, they generally reach temperatures of between 200 and 700 degrees Celsius or 392 and 1292 degrees Fahrenheit, meaning they generally incinerate everything organic they touch. Although I do not have the official key for the coloration shown in infrared camera this infrared footage, I have created an estimated temperature color key based on known temperature of background features in this aforementioned footage. Using this methodology, it appears that these pyroclastic flows reached temperatures of 314 degrees Celsius or 597 degrees Fahrenheit. Now, you might be wondering, exactly how much of these pyroclastic flows are gas when compared to rock? Well, if we base our figure on Vesuvius's 79 CE eruption pyroclastic flows, pyroclastic flow lethality: each cubic meter of a pyroclastic flow contains 0.1% hard rock, lava, and ash, 5.8% volcanic gases that would suffocate a person, and 94.1% regular air. This comes out to a density of 2.84 kilograms per cubic meter of pyroclastic flow. But, you must remember that a speed of 38 miles per hour in the case of Stromboli's July 3 pyroclastic flow when combined with the front-facing surface area of an average person means that a person would be hit with 33.8 kilograms or 74.5 pounds of rock every second. Have you ever wondered why air temperature can reach 80 degrees Celsius in a sauna and not burn your skin while you would instantly receive a severe burn if your skin encountered only 70 degrees Celsius water? The answer is a concept known as thermal conductivity. In other words, the rate at which one object can pass heat to another, with a higher figure indicating a higher rate. While water is 24.2 times more thermally conductive than air, the basaltic rock fragments within a pyroclastic flow from Mount Stromboli would have a thermal conductivity 4 times higher than water. In other words, everything a pyroclastic flow touches would be burned instantaneously. Lava flow: because the collapse of Stromboli's crater removed a decent amount of overlying rock, it widened the vent and allowed an increased amount of lava to erupt during the following several hours. This created a lava flow which more slowly advanced towards the Mediterranean Sea, occurring alongside Strombolian-style eruptive activity that was named after this very volcano. If you are wondering how the pyroclastic flow was able to cross more than 1,000 feet of water, the answer relates to its density being lower than that of water, allowing the current to simply ride on top of the water until it runs out of energy or cools a sufficient amount. Pyroclastic flows are generally uncommon at Mount Stromboli, happening about 1 to 3 times a year. In my opinion, during the next several days to weeks more smaller collapses and thus what could happen next pyroclastic flows could occur, but these will likely be completely confined to its northwestern slope away from populated areas. So, do you have any questions about Mount Stromboli or its recent eruption? Be sure to let me know in the comment section below. As a final note, I would like to thank my new patron VJ for supporting this